Hi there, I'm Bob Plankers. I'm a staff technical marketing architect at VMware Corporation, and it's my pleasure to support VMUG today by talking about virtualization infrastructure security. I got kind of creative with my titles this year for my VMUG submissions. Stop this ride, I want to get off. That's how many of us feel about all of this stuff. You know, why are we always talking about security? Can't we just have a day without security? And no, the answer is no. You know, thank you for playing. But no. So let's talk about it. Before we get into it, I'm so cool. I have a whole bunch of disclaimers. Actually, I've only got one today. The This one's a long way around saying, everyone's environment is different. We'll talk about this in just a second. Like context is really important for security. And what I suggest might not, things I might talk about here might not be a good idea for you, and so you need to sort that out. You need to use your head. And if you don't know what the right answer is, we've got professional services folks that can help you with that. There's security consultancies out in the world and that, but it's it's important. Not everything. It's all a trade-off. Actually, I'm getting ahead of myself. We'll talk about that in just a second here. But my agenda today, just to recap some things, talk about threats and issues. You may have heard me talk about some of the stuff before. What we're doing about threats and issues. We'll talk about vSphere 8 and perhaps a little bit of upcoming releases too. There's these update releases that we have for vSphere and important stuff happening there. I won't get too far into that, but and then some wrap up and resources and things. And so to start with, some level setting. I do like the Adobe stock photo library too, and jokes. I got a dad joke sense of humor here, so this is a surveyor's level. But first stop here, security is always a trade-off. We're always trading off budget and staff time, which is really just a form of budget. Sometimes a sysadmin will to live, idle timeouts. Idle timeouts always drove me nuts. And actually, idle timeouts led to a revelation that we'll talk about in 2 slides here, that compliance can be a negotiation too. And so, but the trade-offs aren't always direct, like trade-off in perhaps system design. We're gonna put an air gap in, and we're gonna design a system that's fully air gapped. Okay, so how are admins gonna get into it? Well, like how do we monitor it? And the trade-offs there for stuff, it might seem like a good idea to do an air gap or whatever, but it adds such tremendous complexity in certain ways that security ends up going down. And so some of that stuff isn't as straightforward as one might hope to have it. Security always depends on context. I was just talking about that your own context is really important in security. What works for one organization doesn't necessarily work for another organization. What works for one workload doesn't necessarily work for another. And that's tricky sometimes. One size fits all tends to hurt. And so that's something at VMware we try to think about. Adding flexibility while retaining, helping people do the right thing, really. And adding flexibility if they need to deviate from from best practices on a workload by workload basis. Last thing, compliance is always a negotiation. You don't really realize this because some dude shows up with a list from some scanner somewhere that has a whole bunch of red X's on it, and to fix, and that's no, go out and read the compliance requirements yourself, and there's such a thing as compensating controls is what they're called. If you can't meet something directly, there's other things you can do to achieve the same goal, just indirectly, and so that's a really interesting revelation when you get there, that you should be able to talk to your auditor about it and work it out. In my case, I mentioned idle timeouts. Idle timeouts were killing me. The 10-minute idle timeouts. Somebody stops in my office to talk to me, and now I'm logged out of everything. And I mentioned this to our compliance guy. He's like, "Well, what do you want them to be set to?" And we'll just document what they're set to. And I'm like, "Whoa, really?" And he said, "Yeah, the important thing is that they're set not crazy high or whatever, but we don't want to interfere with doing work we do want to add security and check to make sure that it's there. And I'm like, oh, holy buckets, that's awesome, And so not everyone has those conversations. So I take this opportunity to say, hey, you might be able to have that conversation. So try it. I mentioned I do have marketing in my title. I mentioned some of our approach to this stuff. Really trying to have a secure platform, have all the capabilities that you will need in order to meet what you're doing, and where we can turn those capabilities on by default. And we really tried a lot of that stuff with vSphere 8, improving the defaults so that like to harden a VM under vSphere 8 and vSphere 8 update 1. Not that talk about futures here, but you really only need to set 2 different things, and the rest default to the security configuration guide suggested setting. You can still set them explicitly if you've got a compliance scanner that cares about that. Yeah, that's fine. You can still, but if you're running vSphere 8 and you can't set that stuff or don't want to, you don't have to anymore. Save some time. Easy to use. Simplification drives adoption. Product manager told me that a couple of years ago, and he was absolutely right. When it's easy to do the right thing, and my saying has always been, make it easy to do the right thing. Like when it's easy to do that right thing, people will actually do it, and it saves staff time and things. A lot of security becomes this nitpicky stuff, and that just sucks staff time. Like can we do it in an automated form? Can we do it by default? And then can we report on it for compliance? And then can we do it everywhere? Gaps between products and that. vSphere supports a lot of stuff. VCF, can we make it so that VCF also supports the same recommendations? Disastigs have them, all this stuff follows through to all of these other things. We used to have a marketing campaign called It All Starts with vSphere, and that's true from a security perspective as well. And so we're really proud of that. Looking at vSphere itself, it's kind of like I don't want to use the term onion. I often say, like it's kind of like an onion, all the different layers, and you cry every time you peel one. Actually, I don't want to describe it that way. Like there's good stuff in here. And at the hardware level, we've got Secure Boot. Secure Boot, by the way, it's been around for 13 years. Please turn it on. It helps with stuff. The Mandiant report that came out last fall about rogue VIBs being installed and things. With invalid signatures, that stuff wouldn't fly if Secure Boot were turned on. That is the single fix for that. Turn on Secure Boot, and then that doesn't happen. You're not affected by that stuff. Hardware TPMs, trusted platform modules. They enable ESXi to store secrets in a secure way. TPMs do basically 3 things. They help with machine identity. They've got a really slow random number generator that helps seed the entropy engines, the pseudo-random number generators that are in ESXi, which are fast, but we get randomness from this thing, and entropy, so that we have good random numbers for our cryptography inside of the product. And then it's a secure enclave to store secrets, not wholly unlike, my iPhone. We hear law enforcement complain about iPhones and secure enclaves where they can't get, criminals' secrets out of there, and I think, hey, I want that for my own secrets too, and so TPM basically does that for an on-premises server, is that secure enclave, and that helps immensely. Of course, if an attacker can steal the whole host, they'll get those secrets too. So, things that store the secrets there, ESXi configuration encryption, native key provider in that. If you don't have physical security of your host, then yeah, that's another consideration. But SEVES is something that you can turn on at the hardware level. It helps secure encrypted virtualization with encrypted state. So secure encrypted virtualization is just memory encryption, in-use memory encryption. Encrypted state is the registers in the CPU are encrypted too. And AMD basically future-proofed their CPUs against future CPU vulnerabilities using this. If you've got operating systems, guest OSs that support it, you can turn it on all the way through the stack, and it's really cool. There's some considerations there. So actually, if you want to turn it on and use it, the considerations are basically you can't vMotion. You're keeping secrets from ESXi. But you can still cold vMotion, but you can't hot vMotion. And but Tanzu, where Kubernetes is just destroying a cluster and redeploying it somewhere else, actually works really well with the containers. And so, at any rate, TXT, where you see that turn it on, we can use that for additional verification of things. This is at the hardware level. We step up to ESXi, we've got signed VIBs and exec installed only. Exec installed only, we'll talk about that in a little bit with vSphere 8. It's turned on by default and can't be shut off without big warnings showing up. Undismissible warnings. You've turned off a core security feature. Exec installed only means that you can only run binaries that have been installed from a signed VIB. Only run legitimate software that you've installed. Or an attacker, perhaps, that has admin rights to your hosts, so don't let them have admin rights to your host. You'd think I'm joking. I'm not. Configuration encryption. With vSphere 7 Update 2, we started encrypting the configuration data for ESXi on disk, and so it's not writing configuration secrets to the boot volumes in the clear anymore. If you have a TPM, it'll store the key for that in the TPM. If you don't have a TPM, it'll store the key on disk right next to it. So if you don't have a TPM, net effect is about the same as it was before. If you do have a TPM, it's more secure because you've got Lifecycle. You can repurpose SSDs. You can't sanitize SSDs, and not very effectively because of the wear leveling and that on them. And so this helps immensely with that. Key persistence and sealing, that's what we do. So sealing is what we do with a TPM. We seal a secret in there. And what we can do is we can take an encryption key and we can seal an encryption key in there if we want, and we call that key persistence. Most places don't want to do that, but you don't want your secrets to be in the TPM permanently. But if you want to build an ESXi host that has an encrypted VM that's on a truck, for example, or on a boat or whatever, this might be an interesting option for more mobile environments and that. Flexibility. Again, having flexibility is really cool. CPU schedulers. We've got the different CPU schedulers for the side channel CPU vulnerabilities. CPU vulnerabilities are not a problem with vSphere. They're a problem in hardware. And it's been a while since we've had one. Are we done with it? Probably not. I don't know. But we've got the 3 different CPU schedulers. The default one that completely doesn't use hyperthreading at all, and then another one that only allows hyperthreading inside of a VM. So 2 virtual CPUs in a VM can be hyperthreaded if we want. And that's nice. It lets lets organizations like yours choose how you want to respond because there's performance implications. You get rid of hyperthreading, you get rid of about 40% of your CPU capacity. Are you more secure? Maybe. Again, that trade-off is not necessarily direct, and so it's something to think about. And then a VM sandbox. Around something we added in vSphere 7 is, so there's a concept of VM escape, and where an attacker gets into a workload and then can do something to basically end up in the hypervisor itself and sort of behind all the defenses, and that's not cool. And so the fix for that is really just a patch when those problems show up. But can we do something in the meantime to help mitigate those sorts of things and the potential for it? And so, as it turns out, a running VM, we know all the system calls it's going to make to ESXi. And why don't we build a sandbox so if it tries anything else, we catch that. We alarm on it, we shut the VM off, that sort of thing. And so, we call that the sandbox. And VMware participates in a number of different hacking contests and bug bounty programs and things. And when we buy a vulnerability when somebody comes to us and says, we found a problem in whatever, and we buy it from them, we reward them. We'll often talk to them as well, ask them to talk to engineering and that. And invariably, they tell us that they hate the sandbox. And that just makes us smile because we like it when attackers hate our defenses. That's the whole point. So, moving up up in the stack at the vCenter server level, if we've got a TPM, we can do host attestation. Secure Boot stores things in the host trusted platform module that can help with machine identity and verification of the boot processes, and that vCenter server will come along and verify all that stuff and say, hey, this host is running in a good configuration and cryptographically secure, or cryptographically sound as far as what loaded at boot, all that stuff. And so that's nice. Trust authority then comes along. There's really no, if you fail host attestation, there's really no penalty though, but trust authority comes along and says, hey, what if we had some penalties? What if you fail host attestation? Why don't we deny you access to the cluster? Why don't we kick the host out of the cluster? Why don't we deny it access to the cryptographic keys? And that we're not going to give secrets to an untrustworthy device, and so that's pretty cool as well. Native key provider. So there's standard key providers that use an external key management system to store encryption keys. Native key provider allows vSphere to do that internally as well. And so you can turn on VTPMs, VM encryption, vSAN encryption really easily now. And that's huge for a lot of customers. But again, there's some considerations for the design there. Most notably, if it's that if your host is stolen, because native key provider stores a decryption key on the host itself and the TPM if there is one available. And so if somebody steals your host, they get the ability to unlock the workloads. And so a lot of remote branch offices, remote offices, retail businesses, things like that, where physical security isn't a guarantee, still want to use the standard key provider. Identity federation. VM and vSAN encryption, kind of talked about that, being able to encrypt wherever you are. They're nicely flexible. VTPMs are built on top of VM encryption. But identity federation, the ability to federate with ADFS, and if you keep your eye on vSphere 8 Update 1, talking about futures here or whatever, some additional things there. We're bringing the Workspace ONE broker into vCenter server itself. And so Workspace ONE broker knows how to talk to all these different federated services like Okta in that. And so, if you're part of the continuous beta, you've already seen the Okta support in there. And so that's, and if you're not part of the continuous beta, reach out to your sales team and see if you can get to be part of it. The answer is probably yes, And so, being able to federate directly with cloud identity providers, really decent step forward as far as bringing MFA and improving the identity management inside the infrastructure itself. But you still have to watch out for that, because those central identity management tools, AD and all that stuff, they are big targets for attackers, and so, should you build some isolation between your infrastructure and your workloads? Should you use the same AD that all your desktops are logging into? Desktops are a big initial access point for attackers, that sort of thing. Subject of a lot of this is design stuff. A lot of subject of, we could talk for hours. We probably should talk for hours about this. Then vMotion, DRS, vSphere high availability, fault tolerance. People don't label those as security features, but they're absolutely security features. Security is confidentiality, integrity, and availability, and these are availability tools, right? So they also enable patching. Patching is key. I know I talk about patching a lot, but patching is key for removing vulnerabilities from environments. There's no other way to remove a vulnerability unless you patch. So at the workload level, we've got virtual TPMs that enable workloads to keep secrets and pass compliance checks and things, and virtualization-based security, so we can turn on. We support all of the Windows 11, device and Windows Server 2016, 2019, 2022, device guard, credential guard, all of those advanced features inside that. Turn on VBS. It's a checkbox in the VM configuration, and you're good to go. vSGX, the Intel SGX software guard extensions, kind of like AMD SEVS, except Intel went a little further. SGX really attests a workload to a piece of hardware, binds them together. That becomes kind of an operational issue sometimes, because you can't even cold vMotion it off that host, But if you have an application that supports it and wants to use it, we support it all the way through. And so, in fact, vSphere 8 improved the support for it. Then, of course, on top of it, we've got solutions that we're building, the cloud foundations and VMware Cloud and all that stuff that fit in there really nicely. And so, but just kind of walking through the stack. When I talk about current topics in security, I kind of often feel like I'm talking about the same thing over and over again. So I kind of wanted to take a step back and talk about the different layers there and the different things that we can turn on and we can leave turned on, that are turned on by default. and that people like yourselves should leave on and enjoy and use and be able to point out to your compliance auditors too. So let's pivot for a second and talk about threats. We think about this sort of operation as a threat. This is what our threats look like. It's probably a guy in a hoodie, in a smoky room. Is there something burning there? It's probably not good for their lungs. Why do I care? They're an attacker, right? But all that blue light. No wonder they can't sleep at night. All that blue light. But my joking aside, this is what we'd like. This is what we think of because movies have told us that. But our attackers actually look like businesses. They're big businesses. They've got CEOs, they've got managers, they've got holiday parties, they've got OKRs. They've got employees that are worried about passing their next performance review. This came up on Twitter not that long ago. That the idea that an advanced persistent threat, an APT group, basically had HR, yeah, and I've been talking about this for a while. They're businesses, and they're businesses to defraud us, to steal our intellectual property, well, ours, our mutual, yours, mine, extort money from us, and they're big businesses. And a lot of them are protected by their governments. There's a reason a lot of ransomware won't detonate, won't activate on systems with a Cyrillic keyboard installed, for example. That's pretty telling right there. So, but they're businesses and they're methodical, they're patient, and we have to remember that. These breaches take better parts of years sometimes. IBM did a study a couple of years back that said that a breach ending in ransomware, and that's the thing about ransomware. Ransomware is the end of a breach. Okay, it's not the breach itself; it's the end of a breach. And so often there's exfiltration of data. They'll steal all your data and rummage through it to see if they can extort money from you or your customers. Ransomware is just the last thing there. And so IBM, anyhow, back to my point, IBM, they found that the average amount of time between the breach and ransomware was 341 days. That's the average amount. Imagine how much further, that's the middle, not median, but average, So, yeah, that means breaches are really long, and we need to worry about that, We'll talk about ESXi ARGs in a minute here. ESXi ARGs, the latest nastiness there, is a little different in that they jump straight to the ransomware. They're just creating chaos or whatever. That's not typical, and we need to remember that when we're talking about this stuff. How are attackers getting in? They're getting in through our humans. Our humans. It would be, my job would be great if it weren't for the customer's sort of mentality. I'm not complaining about you, but that old adage or whatever that sysadmins often have. My job would be great if it weren't for the users. I love customers. I love our users, but humans are going to human, right? They're going to do dumb stuff. And, as a human myself, I can speak to this. I've done a few dumb things in my life, and just a couple, and those that know me know I'm lying. It's much more than a couple, but humans are going to click on links, especially as I get older and I discover that the URLs for, those URLs that I'm being sent, my phone gets a little bit farther from my face. Will I be able to tell Unicode characters? Will I be able to tell something that looks like an A but is a Unicode character from an actual A? I don't know. Maybe. I don't know. And so we're going to click on stuff. And, I don't blame humans for doing this stuff. We just need to be prepared for when they do. It's inevitable, And so an attacker now has control of a desktop. They now have a set of compromised credentials, perhaps, something that they can authenticate to Active Directory and to that central AD that everyone's got, and that also makes vulnerabilities a little different. You think about the vulnerability scoring system, the common vulnerability scoring system, CVSS, 0 to 10, 10 being the worst. Many of those scores are rated based on the fact that you need to authenticate. An attacker, in order to use it to exploit a vulnerability, might need to actually have a login to the system to do that. Well, maybe they do now. and that remember that vulnerabilities, when they're disclosed by vendors, are always scored from the vendor's perspective, and so most organizations that are security conscious are starting to assume that a desktop is compromised, a set of credentials in Active Directory is compromised. And so how do they prevent further lateral movement, is the term, further lateral movement there of the attackers? How do they prevent that? Software vulnerabilities, another big one, and we see this with VMware, VMware products themselves, the unpatched vulnerabilities from 3 years ago that aren't patched, and it's a hole sitting there. And maybe you've got firewalls in front of it, but what happens if something happens to that firewall? I know of one organization that hasn't patched in a long time, and they got hit by the ESXi ARGs thing because, as it turns out, their firewall had been disabled, and disabled or compromised at some point too, and so they didn't have the defense in depth that they thought they did, and so better to take care of this stuff and get rid of these software vulnerabilities. So how do we do that? Well, TPM 2.0, mentioned that earlier, add it to your ESXi host. Please don't buy new hardware that doesn't have a TPM in it. You can't get a desktop that doesn't have a TPM in it at this point. Why we're still shipping servers, well, we don't ship servers, but why humanity still builds servers that don't have TPMs in them is just beyond me. But something for the Dells and HPs and Lenovo's of the world to take up. But VMs as well. Add VTPMs to them where they need that. Please, even if you don't do TPM, turn on Secure Boot. Like I said, it's been around for 13 years now. Turn it on, allow it to do cryptographic verification of the bootloaders and things. This is helpful for stopping things. Can it be a pain at times? Yeah, but the pains are largely have been resolved, and unless you're rolling your own Linux kernels and that, you're not going to see the pain that people complain about. It works great for 99% of everyone, that sort of thing. Enable EVC and vMotion. People don't turn on enhanced vMotion compatibility because people think that it impacts performance and things. And what EVC does is basically smooths out the differences between CPU families. And so, 3 years ago when I bought my current cluster, my 16 host cluster, that was great. But I filled it up now, and now I want to add 16 more hosts to it, but I don't want to buy the old CPUs. But if I mix and match CPUs, VMs can't move back and forth with vMotion, and that's a problem. Well, EVC fixes that. And can it mask out? What it does is it masks out CPU features that are incompatible among the family. And so, can it mask out things that workloads might need to use in order to perform better? Yeah, it can. But when that happens, you can use per VM EVC to change the EVC level. So basically you're picking the minimum, the sort of lowest common denominator, or highest common denominator, I guess, for a CPU instruction set, but on a VM by VM basis, you can customize that too. So performance problems, gone. Turn it on. Use vMotion. Those app admins that don't let you vMotion got a complete rewrite in vSphere 7 and got updates in vSphere 8. So, we've got customers that are telling us that they have real-time warehouse management workloads running to these huge hundreds of thousands of square foot warehouses that are automated using an application running on vSphere. And they used to need to shut that application down, shut the whole warehouse down, so that they could vMotion the host and patch all that stuff. They don't need to do that anymore, and that I consider to be a gigantic win. And so that's really cool. vMotion in vSphere 7, whatever you're complaining about, is probably fixed. Isolation and monitoring. Why can your CEO's desktop get to the ESXi management interface? We're not one big happy family. You put walls in there, put walls and isolation in there. Monitor for people attempting to get through those walls. Something trying to get through there that isn't authorized should end up in a log that somebody's reading, or as an alert in a monitoring system. Build these things so that Because these breaches are really long, and because these attackers are patient, they will take their time. And we need to be able to catch them. We need to be able to make it hard for them to move around. When they compromise a desktop, we need to make it hard for them to compromise more things. And so, put in that isolation, build the monitoring in there, like that sort of thing. Separate your authentication and your authorization. So if you have to use a centralized directory service like a central AD for vSphere, don't do your authorization there too. Don't use an AD group called vSphere admins to govern who's an admin on vSphere. Do that in SSO, and do this for firewalls. Don't do it at all for your infrastructure. Because an attacker who gets into AD can just add themselves to the vSphere admins group or to the storage admins group, backup admins group, firewall admins group, and it's game over for your entire organization. And you got to make it harder for them. So, at the very least, they have to compromise somebody an account that is actually an admin. So if I have to log in with my AD account, my plankers at my local lab AD, at least the attacker needs to compromise plankers because they can't change the authorization. So compromising my plankers account has a good chance of me noticing because I'm not going to be able to log in anymore. I'll go to my AD admin, which in my lab's case is me. I'll look at the log. We'll look at the logs together, and then my AD admin said, "Well, Bob, you changed your password last Tuesday or whatever." And I said, "I'll say, well, no, I didn't." And then we'll look further. Oh my goodness, we're in trouble. These are design concepts, kind of like zero trust. Zero trust has kind of died off as a buzzword, and I'm glad for it. But the idea still is around. And I'd like to joke, zero trust is a design concept. You plan for it, you design it in from the beginning, you retrofit your environments as they go to stop trusting devices. Just because there's a user at my desktop does not mean it's me. Just because there's an access attempt coming from my desktop does not mean it's me. Could be an attacker. So always verify. We used to trust but verify, Cold War, nuclear arms sort of thing. No, always verify, no trust. That's the way it needs to go. And at the infrastructure level, it gets a little different. There's some divergence there because we need to trust things implicitly. But yeah, my main point though is that you can't just buy a zero trust. I'd like the Adobe stock library. And you can't just walk up to a counter and say, "Hey, I'd like 3 zero trusts." It just doesn't work that way. And I already mentioned, what about ransomware? Ransomware being the end stage of a breach. Exfiltration of data. And, we often get asked, how do we patch for ransomware? Yeah, that's not how it works. You patch for vulnerabilities that ransomware can use, but you harden systems. And we also get asked to comment on ransomware toolkits or attacks. We don't do that at VMware. We don't want to encourage them. Two, the attackers, what are we going to say? The attackers they're as clever as we can be because, we like to put together toolkits and things. You and I like toolkits to help us do our jobs. That's really what the attackers are doing, except they're giving them names like Lockbit, and then scary, like it's just a toolkit, and so if you have good security fundamentals, you're in a good spot to defend yourself against these things, but again, ransomware is the end of the whole thing. It's not the beginning, and it's not it's a very noisy end of it. But I said I'd talk about ESXi ARGs, the sort of elephant in the room. Lately, at least, it's kind of dying down now. We've got a Q&A for it. Often, because we don't comment on things, it will often seem like VMware isn't paying attention. We are paying attention, but again, we don't want to encourage this stuff. We don't want to comment on it. We don't necessarily, if we don't have to, because we don't want to give the attackers publicity. There's no way to. What is it, P.T. Barnum? There's no such thing as bad publicity. That works for ransomware or for attackers as well, and so we don't want to accidentally give them publicity too. But eventually the media will make enough publicity for them, not realizing what they're doing. And so we'll come out with a Q&A or whatever. There's one up on core.vmware.com for this. And so, yeah, if you're still having questions or whatever, and the next one, I'm under no. Will there be a next ransomware toolkit? Yes. Will somebody come along and find a way to fast attack a whole bunch of unpatched ESXi again? Yeah, they will. Like I'm a realist about this sort of thing. People don't patch very well or at all, and and we'll have something like this. So when this happens, go out to core.vmware.com, check our security blog, check our VMware response center. The security response center does this. But another thing, along the lines of, how do I patch ESXi ARGs? Well, you apply patches from 3 years ago is what it amounts to, But in this case, ESXi ARGs was also something that we can't. Our recommendation was to come up to the current levels. We don't know. Attackers don't tell us what they're doing. If we ever find out how an attack is working, it's because a threat hunter, some sort of intelligence gathering operation has watched them conduct the attack and figured it out. But the speculation that the OpenSLP vulnerabilities were used, yeah, we've got some evidence that was the case, but we've also got evidence that they're using other vulnerabilities. And so again, attackers don't tell us what their plans are. So our recommendation is always just to stay patched. So yeah. Well, and I mentioned the ways we were talking about ways organizations are being compromised. I didn't talk about insider threats or configuration mistakes too much, but actually the numbers on the bottom of these things, that IBM study I mentioned, that's the average amount of time that from a breach to detection of the breach, or containment of the breach. I'm sorry. That was resulted from a configuration mistake or an insider threat. Insider threats are nasty. CISA.gov, CISA.gov has got a really great page on dealing with insider threats, and that's something that IT can learn a lot from the financial institutions of the world. Banks, mandatory vacation time for bank staff, to help expose fraud and fraudulent behavior and things. Stuff like that. There's a lot of stuff there, but CISA's documented a lot of it, so go check it out. And as I mentioned, the divergence between how infrastructure protects itself and how we protect workloads. Because workloads, it's a lot easier to do zero trust. It's a lot easier to encapsulate them in protections, NSX and that. But, at the infrastructure layer, we have to trust. We trust a network switch, just implicitly. We trust our storage. How do we get our storage? Do we want to re-authenticate every time we do a storage operation? No, that's going to drag on performance, for example. So there's trade-offs. How we protect infrastructure is different than how we protect workloads, and that's intentional. We build the trust mechanisms at the infrastructure layer look different and act different, and it's important to keep that in mind. So let's get into vSphere 8. A couple of things from vSphere 7 that we've kind of talked about already, but just that you might not have caught. Configuration encryption, I mentioned earlier that we encrypt configuration data, ESXi configuration data on disk now, so that's good. Native key provider, talked about that, enables vSphere to enable encryption on its own. RAM disk ESXi OS images. We get people, especially in the compliance space, that like to go in and edit SSHD_config, and then they wonder when they patch, or reboot, actually, when they reboot, why those changes went away. Well, they were editing an in-memory copy of the operating system. Everything at boot gets reloaded from disk into a RAM disk. The operating system's running out of a RAM disk. And so, one, that's good. You'll always get a known state there. Two, if you're trying to customize things, don't use the official APIs. SSH is not a supported way of managing the hosts. Not really. It's a support and troubleshooting. It's a troubleshooting tool, and it's meant to be off. There's a reason we deliver it off and disabled. It's because it's meant to be off. Use the APIs, and if it's not doing what you need it to do, ask us to improve the product for you. Or chances are we've already done that, and we can show you how to do it. But RAM disks too. This also is how we enforce the signed VIBs and that. So if you're going to update, if you want to customize something, you have to update it with a VIB, and so you have to go through the install process, and that's subject to role-based access control, all that stuff. The other thing I want to mention, though, is if you do have a breach, work it out with your incident response team because of this RAM disk. Work it out with your incident response team whether you should just unplug the network from the host or whether you should shut it off or whatever. Because if you shut it off, you're going to lose a lot of the stuff from an attack. A lot of the evidence. And so work it out what your response should be before you have a problem. And yeah, just something to ask them. If you don't have a response team, might think about developing one or contracting with an outside firm to do response. So that when there's an issue, most organizations that assume that there's going to be an issue tend to be prepared for it. They assume that they're going to get hacked at some point here, and that's going to be that. And so when there's an issue, they know who to call. So you should be that person too. It's not Ghostbusters either. vSphere 8. Let's talk about vSphere 8 a little bit. And I mentioned a little bit about the authentication in Update 1. Update 1's got a lot of the big stuff for security in Update 1 is really behind the scenes. And we'll talk about that in a second. But TLS only. TLS 1.2 only. 1.3 is on the roadmap. Don't worry. Better cipher suites. We still have to support a Windows Server 2012 R2. Until it's supported until October of this year. And that's the one cipher suite that will run afoul of somebody's opinion about secure cipher suites. VMware officially considers all the TLS cipher suites that we're using in the product to be secure and trustworthy. The U.S. federal government does too, whether you support that or not. But we don't. This is not how attackers are getting in. We'll just put it that way. But better cipher suites, vSphere 8 was an opportunity to go through and try to clean that up. And so we did, and there's a lot of work that's been done there. So hopefully you don't have to mess with that too much. That's, again, something that you can go in and change. If you change ESXi, you'll change config files and that, and then you'll reboot and it'll be all gone. So just compensating controls, as I was talking about. If your compliance auditor gets wrapped around the axle over a particular cipher suite, you've got better things to do, like applying patches and things. Work it out, work that stuff out with them so that compensating controls are there. Isolation is often a compensating control. Untrusted binaries, user.exec installed only. The advanced parameter changed a little bit from 7 to 8. It used to be a VM kernel.boot.exec installed only. It's out in user space now. And but this is what prevents unsigned binaries from running. And if somebody sets this to false, by default it's set to true in vSphere 8. If somebody sets it to false, you'll get a banner, you'll get a yellow warning on your host and a banner that's undismissible that says that somebody's doing something that they shouldn't be doing. This is a clue that a human needs to come along and investigate this. And you should check that out because, attackers, if an attacker gets admin credentials into your environment, what are they going to do? They're going to shut security controls off so they can load their toolkit. Their toolkits are not signed by VMware, and because why would we sign an attacker toolkit? And their toolkits are not signed, so they need to shut stuff like this off in order to be able to run them. And so that's a big hint that something's going wrong and that you need to take a look at it and call your incident response folks. More secure product defaults. I mentioned this earlier. We've basically done a whole ton of work between vSphere 7 and 8. Basically 8, we took a look at all of the security configuration guide. Anything that wasn't set by default, we tried to set it by default. There's some stuff we can't, like the number of consoles allowed into a VM, console connections. Right now, it's still the default of 40. We recommend that it get set to 1, but if you set it to 1, that could be a denial of service attack. Security depends on context, right? And so it's, you need to make a call there, and then document why you decided to set it to whatever you did. In my past, I always set it to 2 because one of my coworkers or myself, more often, would sit on a VM console and I'd go to lunch or go home for the weekend or take, 3 weeks off or whatever. And I'm sitting there on the VM console and no one else can get in, and so something to keep in mind, support for 3D graphics. We can suggest shutting that off, but if you do that, there are certain things that don't work, and so At the ESXi level too, NTP servers, DNS servers. We want you to have NTP synchronization, but how you do that, what you set them to, that's up to you, And so, yeah, we're trying to reduce the workload though, trying to get it down to the bare minimum that you need, and document the defaults then too. SHA-1, we get asked about SHA-1 a lot, and we're removing SHA-1. SHA-1, the timeline for like the U.S. Department of Defense for removing SHA-1 from things is like 2030, and so it's not a pressing concern for most organizations, practically speaking, but it shows up on compliance things, and people again get wrapped around the axle when it comes to it. And so, the answer when we get asked, does your product contain or use SHA-1, and we say yes, it does, and people go, oh my goodness, well, it has to be in there for backwards compatibility, and where we're using it, we're getting rid of it. But because of backwards compatibility, it becomes a longer process than just pivoting and doing something different. Not every organization can just stop and reformat all their vSAN volumes, for example, and so this needs to be a process, a life cycle thing. And so we use OpenSSL in our products. OpenSSL supports SHA-1 and will continue to, and so we don't want to do a custom build of OpenSSL or anything like that. So SHA-1 will always be present whether it's being used or not. The most visible thing is right now is when you're adding hosts to a cluster, there's a SHA-1 fingerprint in there, and oh my goodness, that's not how you're getting hacked. Believe me, it's not how you're getting hacked. And so just tell your compliance dude to calm down. So TPM 1.2 was deprecated in vSphere 7 and has been removed in 8. We only support TPM 2.0. You can actually, just like you can buy servers without TPMs, you can buy servers still right now from major vendors with TPM 1.2 in them. Please don't. 2.0. 2.0 is where it's at. VM Virtual Hardware 20 has got new support for CPUs and CPU security features. Hyper-threading, the virtual hyper-threading that exists, that's pretty cool. For a lot of folks, you don't need to mess with it. But if you've got a big workload that would benefit from knowing how the hyper-threading is working underneath, you can do that. There's new vNUMA exposure stuff. You can configure that from the UI, the vSphere client UI. LSI SAS to PV-SCSI. I mentioned this as a security thing. One, LSI SAS driver. That driver is really old, and Microsoft's kind of begging us to stop using it for ages. 2, there's better options out there by default, the NVMe stuff. And 3, we'd rather you be on PV-SCSI anyhow in VMXNet 3, but some folks won't run those drivers because what about VM escapes? There have been VM escapes through them. Well, there have been VM escapes through the E1000 driver as well, and so you need to patch. And you get PV-SCSI VMXNet 3 gets you 40% extra, 40% performance improvement for free, basically. So there's a process now though to convert. You don't have to do the funky shut it down, add an adapter, shut it down again, that sort of stuff. There's an automated process to convert from LSI SAS to PV-SCSI. So look that up. DPUs in vSphere 8, DPU support. This is the Distributed Services Engine is the official name for it. The ESXi on ARM is the worst kept secret we've had ever at VMware, and this is where the ESXi on ARM stuff is showing up. Those are ARM CPUs. It's basically ESXi inside ESXi, and you'll see it mentioned as ESXIO, kind of like Old McDonald, and it's cool. The idea that it's coprocessors. I joke everything old is new again. Mainframes used to have coprocessors for everything, and we're getting that way now too. Coprocessor that can enforce NSX firewall policy at the NIC level. Can do vSAN. Perhaps we can do vSAN. That's a future thing here, but present vSAN data stores to hosts, perhaps to hosts that aren't even running ESXi. What if it could present it to a bare metal Windows or Linux host, and the data store that is just the allocation of the storage is coming from vSAN and the network policy is coming from NSX. That's kind of cool. Seems boring, but we ESXi logging got standardized to RFC 5234 and cleaned up. And that this again seems pretty boring, but security operations centers love this, and it's huge, and so that's really important. The trying to again the detectability of incidents of attacks. We want to be able to see this stuff. ESXi can be pretty chatty at times, trying to curb that as well. And then Lifecycle, really improving the Lifecycle. vSphere 8 and 8 Update 1 will make a bunch of improvements for standalone hosts. Parallel host upgrades, you might say, hey, Bob, didn't we have that with Update Manager? Yeah, we did, but, parallel host upgrades now. Update Manager wasn't that good at it, to be honest with you. It would make some really specious decisions about what to put in maintenance mode and that, and so rethought a lot of that stuff. Update Manager baselines are deprecated, but deprecated again means that it's still supported through the lifespan of vSphere 8. And so you've got, 6 years left to figure out, 5 years? Maybe it's 5 years. 5 years to figure out how to get past the Update Manager baselines, that sort of thing. Configuration profiles are something new. It's a follow-on to host profiles. Doing the Update Manager didn't really care. Backing up a second, Update Manager didn't really care about the configuration of a host. It would just patch whatever was there that it had an update for. Lifecycle Manager cares more deeply about it and does this desired state thing where you define an image. This is how I want my host to look, and then it applies that, and any deviance from that it corrects. We're doing the same thing with host profiles now and configuration profiles, where you define how you want it to look, and then it monitors for drift and is able to remediate in a much better way than host profiles ever did. So that's cool. Cluster key value store, something on the back end. We're trying to make vCenter server less important to a cluster. Why can't those VCLS VMs that everyone loves to hate? They're sticking around, by the way, so get used to them. And by the way, they use the default. They lean into the defaults for vSphere for security things. We get compliance scanners that'll say they're not hardened correctly. They are. They're using the defaults. They only explicitly harden the things that were needed for vSphere 7. And 8 doesn't even require that as much, but we're just leaving it as it is. And so when your compliance scanner finds them, that's the answer to that. But can we use those VCLS VMs for something more there? And so, can the cluster keep track of more of its own state and not have to need vCenter server as much? Yeah. And so this helps, especially if something happens to vCenter server, being able to restore it from a backup. It doesn't need to. You don't get the synchronization problems that you used to. So big things, trying to really smooth out patching in that. And that's important because patching, again, is the only way to eliminate vulnerabilities. So kind of wrapping up here, resources. I always plug the security configuration guide. This is the baseline guidance for hardening vSphere. It's tested, it works. That's actually the biggest thing with vSphere 8 and 8 Update 1 is it doesn't seem like we're doing a lot from the security feature perspective, but we've actually gone through and made all these things the defaults, and so they can get tested and that. And that's something that we can't say for the CIS benchmarks. The CIS is great, and actually I need to work with them on getting the CIS benchmark for vSphere 8 out. But there's also the DISA-STIG. Should you use a DISA-STIG? Should you use a CIS benchmark? Maybe, when it comes out for 8. You can take a look at it and use your head. Should you use a DISA-STIG? Maybe. It's got good ideas in it, but DISA-STIG is a regulatory compliance framework for the U.S. Department of Defense. If you're not the U.S. Department of Defense, it probably does contain things that you probably shouldn't be doing. Like tying your infrastructure to Active Directory, for example. Is it a good data point? Yeah, you should look at it. It's great. And we maintain the way STIGs work is it's our recommendations. We put the recommendations together and we submit it to DISA. DISA reviews it, and then they sign off on it, and then they publish it. And they just published the vSphere 7 STIG as well, and that's cool. But if you need STIG guidance if you need the hardening guidance. We also maintain that stuff at core.vmware.com. Right along with the hardening guides, the compliance enablement stuff. We've got the DISA-STIG stuff in there, and it's all integrated. So hopefully you can harden your environment. But again, those other things, the official stuff is the security configuration guide. If you do nothing else today, please sign up for the Security Advisory mailing list. It's a matter of time. When we disclose a vulnerability, it's a matter of time between when we disclose it and when the attackers start attacking based on it. And there's no way to just tell the good people of the world that there's a problem ahead of time. You can only tell everyone. The bad guys get to hear about it too. And so we want you. We're very transparent about it at VMware. We don't like security problems, and we fix a lot of stuff, and we do a lot of work to prevent them. But stuff gets through, and so we want to be transparent about it. We want you to know the moment it's published, so that you can act on it. And on sort of a petty note, you can know before your InfoSec team asks you if you're a vSphere admin. I always enjoyed knowing ahead of them, knowing before my InfoSec guy, Alan was his name, he'd always show up in my office. Hey, Bob, there's this new security advisor. Yep, I know. It's patched already. In fact, sometimes we'd be able to patch for it faster than they would notice it even. And because we had our patching, we had vMotion. Our patching was a standard change. Our change managers understood that it was non-disruptive. The vMotions that happened, we only had a couple of apps that would notice vMotion, and it was and they picked up right where they left off. It was no big deal, and that was really cool. But I'm going to leave you at this. Sign up for this, and don't just sign up for the VMware one. Go through your configuration management database or your asset inventory. You've got an asset inventory, right? And go through that and make sure that you're signed up for all of those vendors' mailing lists as well, because you want to hear about that stuff too. So I thank you. I hope you are staying safe and healthy and all that stuff. And if you've got any questions, you can reach out. You can find me at Plankers on Twitter. It's my personal account, so your mileage may vary. But you can ask me stuff there. You can reach out through your account team. You can send me an email. I think it was at the beginning of this, rplankers@vmware.com. My inbox is terrible because there's hundreds of thousands of you and there's one little old me. And so, if you don't get a response, ping me again, honestly. So I appreciate it. I appreciate you being our customers. Thank you, and take care.